Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Pure Mathematics 1 for October, November 2024, paper 1-1 for questions from 7 to 11. Question 7, the diagram shows part of the curve with equation y is equal to 12 out of the cube root of 2x plus 1. The point A on the curve has coordinates 7 over 2 and 6. Part A, find the equation of the tangent to the curve at A. Give your answer in the form y is equal to mx plus c. Now, at the point of intersection between the curve and the line has the same gradient as that of the curve. For any straight line, the gradient between any 2 points is always constant. Between this point and this other one here, it is always constant, but the gradient is always different on every point of the curve. So at the point where they meet, the gradient of the curve equates to that of the straight line. Okay, so, and differentiation is the process of finding the gradient of the curve. So we differentiate the equation of the curve, and then that is going to give us the gradient function for the tangent. Okay, so we are having y is equal to, we have y which is equal to 12. I can take the whole of the denominator up, which will be 2x plus 1, then power negative a third. And then we differentiate this. We have this identity that when we differentiate ax plus b power n, we use chain rule. So you drop the power, you will have n into ax plus b, reduce the power by 1, then enter inside and differentiate. So when you differentiate ax plus b, you get a, and then you multiply all through. Now my dy dx is going to be, we drop the power, so the 12 will multiply by the negative a third, which is coming from the power. Then we have 2x plus 1, and then negative a third minus 1, that is negative 4 over 3. And then times the derivative of what is inside here, it gives us a 2. Then we shall have, you know that 3 goes into 12 4 times. Now 4 times 2, we shall get 8. So that means we shall get, our answer is negative 8. Then I can take this one down, 2x plus 1 to the power of 4 over 3. Then at this point A, which is 7 2, that was given, 7 over 2 6. So we shall now get the gradient of the tangent. Gradient of tangent. Remember, to get the equation of a straight line, you need to get the gradient and a point, at least one point through which the line passes. So we shall substitute here, and we have negative 8 out of 2, then times 7 over 2, then plus 1, then to the power of 4 over 3. So this one will give us negative 8 out of course, this 2 will go. Then we have 8 here, power of 4 over 3. Now, 8 power third, that is the cube root of 8. That one gives us 2. Then 2 power 4 is 16. So we shall get negative 8 over 16, which will actually give us negative a half. So that is the gradient of the tangent. Now using y minus y1, which is equal to m into x minus x1 as the general equation of a straight line. So we shall say y minus 6, which is equal to negative a half. Then x minus, our x1 is this 7 over 2. And then we make y the subject. We open the brackets here, we shall have negative x out of 2, then plus 7 out of 4. And then when you take the 6 this other side, you get it as a positive. And then simplifying this one, we shall say 4 times 6, you will get 24. 24 plus 7, that one gives us 31. So we shall have y is equal to negative a half of x, then plus 31 out of 4 as our final answer. Part B, find the area of the region bounded by the curve and the lines x is equal to 0, x is equal to 7 over 2, and y is equal to 0. So when we check back here, our region they are talking about is this one here. So we just need to integrate from the x coordinate here, which is 0, the origin, and then here 7 over 2. The one x is equal to 0 is the y-axis here. So we are going to substitute in here, and we say that the area shall be equal to the integral from 0 to 7 over 2. Then the equation of our curve is 12 into 2x plus 1 to the power of negative a third dx. And you know, when we integrate, you remove the integral sign, don't bring it back. Okay, so I can put it, actually I can put the 12 out, then I integrate, so I bring these brackets. Now you increase the power by 1, so I'll have negative a third plus 1, then I divide by that new power, negative a third plus 1, then I will multiply by the derivative of what is inside here, which is a 2. We have, this one is extracted from integrating a to b. No. Let me remove this. Integrating ax plus b to the power of n with respect to x, we have ax plus b to the power of n plus 1. We divide by n plus 1. There is chain rule involved. Okay, in the differentiation, remember integration is the reverse of the differentiation. So in this other one here, we were multiplying through. Okay, we multiplied. Then in the integration, the reverse of that multiplication is division. Okay, now we now come back to this one here. 3 times 1, you get 3, minus 1, you'll get 2. So that means we shall have 12, and then times, I can actually put this constant that is down here outside also. Okay, so we shall have 2 over 3 times 2. In fact, let me just put it here. That will be 4 over 3. Okay, 4 over 3. And then inside here, we are having 2x plus 1, then to the power of 2 over 3. Remember our limits are 7 over 2 and then 0. So the 3 will somersault and go up here. Of course, 4 goes here 3 times. So 3, when it somersaults and finds that 3, it becomes a 9. So we shall have a 9 here. And then we can put the limits. So 2, then times 7 over 2 plus 1. And after we shall put 2 over 3 as the power. Then we subtract. Now we put 0. Of course, then 2 over 3. Shall have the power as 2 over 3. Then here you have 9. So this one will cancel with that. And then you have 8. 8 power third, you get 2. Then 2 squared is 4. Then we shall subtract a 1. So that means we shall have 9 times 3, which actually becomes 27. So our answer is 27. Question 8, part A, it is given that beta is an angle between 90 degrees and 180 degrees, that is an obtuse angle, such that sine of beta is equal to A. Express tan squared beta minus 3 sine beta cos beta in terms of A. So I'm going to draw my 4 quadrants, okay? My 4 quadrants here. And We put A here. All sine, tan, and cos are positive in the first quadrant. Only sine positive in the second quadrant. Only tan positive in the third quadrant. Only cos positive in the fourth quadrant. Then we can have 0 degrees. This is 360 degrees. And of course, this is 90, then 180. When you go anti-clockwise, the angles are positive, right? Then when you go clockwise, they are negative. Then here 270. Now, since they say that beta is an angle between 90 and 180, then I'm going to draw my triangle in the second quadrant. So it is here. So after drawing this angle, the triangle, it's a right angle triangle. And for right angle triangles, we can use SOHCAHTOA. So since sine beta is given as A, then we can have something here like this. Sine beta is the same as A over 1. So we are using here SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse. So the opposite is A. The hypotenuse is 1. Then I need to get the adjacent here, okay, to this angle. Let me just make it beta. Now, we are going to have A squared using Pythagoras theorem, okay, using Pythagoras theorem. Pythagoras theorem, we can have A squared plus the adjacent squared is equal to 1 squared. That means adjacent, okay, adjacent is going to be the square root of 1 minus A squared. Now, in the second quadrant, it is only sine that is positive. The rest are negative. So this simply implies that cos of beta is going to be equal to adjacent over hypotenuse, right? It is adjacent over hypotenuse. So your adjacent is this square root of 1 minus A squared over the hypotenuse is 1, but it is negative in the first quadrant, okay? Then next, also tan beta. Tan beta is also negative. So tan is opposite, which is A, over hypotenuse. Adjacent, which we have gotten as square root of 1 minus A squared, which is negative in the second quadrant. Now, we are told to express tan squared beta minus 3 sine beta cos beta in terms of A. So I'll just substitute here tan squared beta. I'm going to get the whole of this minus A out of the square root of 1 minus A squared. Then we square it, and then minus 3 times sine beta is A, but then cosine of beta is negative root of 1 minus A squared. And then this one here will give us, when you square the negative, it becomes a positive, so we shall have A squared. Then out of the square root now will go, then 1 minus A squared. And a negative times a negative, you get a positive, so we shall get plus 3A, then the square root of 1 minus A squared. So this will be our answer. Alternatively, by the way, you could find cosine of beta like this, okay? Alternatively, we have the Pythagorean identity for in trigonometry. So we have cosine squared of beta is going to be 1 minus the sine squared of beta. So meaning cos of beta will be equal to the square root of 1 minus sine squared beta. So you could have 1 minus sine of beta was given as a. So you can see that we have that square root of 1 minus this a squared. Okay, the same thing that we got here, but remember in the second quadrant, cosine is negative, so you would put that negative there. Okay, all right. And then maybe the next one could be how then to find tan. You know that tan, so here on cosine, I'm going to put that. In fact, let me just put plus or minus, because whenever you take a square root, you have plus or minus. But for this substitution, because we are in the second quadrant, cos is going to be a negative. Now, tan of beta is going to be sine of beta over cosine of beta. So sine of beta is a over the cosine of beta, the square root of 1 minus a squared, but in the second quadrant, it is going to be a negative. And then you come here and substitute accordingly. Part B, solve the equation sine squared theta plus 2 cos squared theta is equal to 4 sine theta plus 3. Now we have a mixture of sine and cosine. So you look at the one which is not squared. That is the one that you're supposed to express everything into. Okay. So it is sine theta. You can see there is sine theta here. So using the Pythagorean identity, sine squared theta, then plus 2, where there is cosine, we shall put 1 minus sine squared theta, which is now equal to 4 sine of theta plus 3. So we open the brackets, we have sine squared theta plus 2 minus 2 sine squared theta, which is equal to 4 sine theta plus 3. Then I can take everything the other side such that the coefficient of sine squared is positive. First of all, 1 minus 2, you get a negative 1. So we shall get negative sine squared theta. Now let it cross, then we shall have sine squared theta. Then it finds the 4 sine theta. And then this 2, when it crosses, it's a minus. So 3 minus 1, we get a 1, which is equal to 0. Now this is a quadratic in sine theta, and this one I think cannot be factorized. So we solve using the quadratic formula. So sine theta is therefore going to be minus b plus or minus to the root of b squared minus 4ac out of 2a. Now, this is negative 4 plus or minus 16 minus 4, that is 12. So we have root of 12. And root of 12 is the same as 2 root 3. So I can write 4 plus or minus 2 root 3. Then simplified, negative 4 divided by 2, you get negative 2. And then 2 divided by 2, you get 1. So we have that. Then I can draw my circle again here. When I draw the 4 quadrants, the 4 quadrants here, we have A, S, T, and C. So 0, 90, 180, 270, 360 degrees. Now, we have here in the angle in the first quadrant, so that can be the theta. If I project it here, opposite angles are equal, so this will be now 180 plus theta. It is theta because 180 plus theta because now we are considering moving up to here. Okay, that is that. Then we also have this one here. If I put a theta here, this now will be 360 minus the theta. You are moving from here to come up to here. Okay, then Also here, I can put the theta here, so that means we shall have 180 minus the theta. Now, these two values, we are supposed to solve theta from there. So theta is equal to -2, okay, then plus root of 3. When you check that value on the calculator, -2 plus root of 3 must be a negative. It's a negative. So we go to the quadrants where sign is negative, and sign is negative here in the third quadrant and fourth quadrant. Okay, so what you can do is to ignore the negative. Okay, is to ignore the negative. So you bring your calculator here and you say arc sine of that -2 plus root of 3. Make sure you check the mode of your calculator so it is in degrees. It will give us -15. Okay, so our theta theta is equal to the arc sine of -2 plus root of 3, okay, which is giving -15. So you keep the -15 point, was it 0.5? Yes, 0.5. You keep it somewhere there. So now our theta, where it is negative, let's check the domain. The domain is from 0 to 360 degrees. So we have to take this third quadrant and the fourth quadrant. Now, I will say in the third quadrant, it is 180, then plus that acute angle you have gotten. Okay, when you ignore the negative, you get that positive angle. And then the other one will be 360 degrees minus that 15.5. And then your theta becomes 195.5 degrees. And then the other one is 344.5. So these are the two answers. When you check this one, this other one here, I've taken only one value here, but we can also have sine of theta, which is equal to -2 minus root of 3. Okay, this one is undefined, okay, because sine does not go beyond -1, okay, does not go beyond that. Actually, when you check here, sine, I propose y is equal to sine of x. Okay, so you can see that it doesn't go beyond a 1. Its maximum is a 1, and then the minimum is on -1. So when you put -2 minus root of 3, that is -3.721 and the rest of those figures. So you can't get a solution. That line cannot meet the curve. Okay, so that's why we leave that out. Question 9, the equation of a curve is y is equal to 4 plus 5x plus 6x squared minus 3x cubed. Part A, find the set of values of x for which y decreases as x decreases. This one here means that dy dx is a negative, okay, is less than 0. As x increases, y is decreasing, so we are having something like that. Okay, so that is that. Now we need to find dy dx. So if our y is 4 plus 5x plus 6x squared minus 3x cubed, then dy dx is going to be equal to, of course, when you differentiate a constant, it goes. Then when you differentiate 5x, you get 5. Then plus 6x squared, when differentiated, we get 12x. And then minus, when you differentiate 3x cubed, you get 9x squared. Then we say this one is less than what? 0. Now, this is a quadratic inequality. I can choose to multiply it by -1, So if I multiply all through by -1. Why am I doing so? I want to deal with the coefficient of x squared, with the positive coefficient of x squared. So we shall have 9x squared minus 12x minus 5. Now, of course, for inequalities, when you multiply or divide through by negative, the sign changes. So I will change this sign to this. Okay. Then, without wasting time, I'm supposed to solve that quadratic. So I can get my calculator here and I put everything in there. This is 5. Then quadratic is 3. Then the coefficient of x squared is 9. The coefficient of x is -12. Then the coefficient, the constant part is -5. Then I get 5 over 3 and -1 over 3. So I can keep these ones here. I have -1 over 3 and then 5 over 3. So if x is equal to -1 over 3 and also x is equal to 5 over 3, I need factors. Okay, so in the schemes they always put attempt to solve the quadratic. Okay, now when you just write your answers like this, you are going to lose marks. Okay, so give us the factors from which these come. Okay, so cross multiply, you get 3x. Then bring the -1 here, it becomes a plus. Okay, then also here cross multiply, you get 3x, and then bring this one here, you get a -5, that is greater than 0. Okay, I can even rub off this, and then I write these as my critical values, -1/3, and this one is 5 over 3. Now, since the coefficient of x squared here, I made it positive, then this means that here I'm having a U-shaped curve. Okay, and for that U-shaped curve, what we have gotten here are the boundary points, the critical values. So -1/3, you arrange them in that ascending order. So this is the minus because it is below. The y value is below x-axis and negative. Then above x-axis are positive, and also this one positive. Now here we are looking for the positive greater than 0. Okay, greater than 0. So we are going now to take the set of values, they mean inequality. So we shall have x less than -1/3. And also because when you get an x value less than -1/3, you get the y value up this side because this one is continuing like that. So it is positive, you see? Okay, then next, also this other side, x greater than 5 over 3. So our answers have to be those. X greater than 5 over 3 and then x less than -1/3. Alternatively, suppose you used this one here. Okay, suppose you used, so let me also write it here, alternatively, you can have your 9x squared, -9x squared plus 12x plus 5, and was less than 0. So since the coefficient of x squared is a negative, that one is going to give us an N-shaped curve. Okay, now if I put this one in the calculator, okay, -9, then I put +12, and I also put 5, it is going to give me the same values, 5 over 3, okay, and -1/3, 5 over 3 and -1/3, okay, x is equal to 5 over 3 and x is equal to -1/3. Now, when you try to bring them back, you will get 3x minus 5 and also 3x plus 1. You see? But when you multiply them, 3x times 3x, you don't get negative 9x squared. So what do you do in such a case? That's why I advise that you multiply all through by a negative 1, such that you change the coefficient of x squared to be a positive. Okay. However, here you can write, you can factorize this one this way. So this is what we are having. Now that means for me to get negative 9x, one of the 3x's must be a negative. So I'll write negative 3x. Okay. Then I also write another one as a positive 1. So remember, my answers are 5 over 3. So I can make this one a minus here, so that it gives me that 5 over 3. And then this one minus 1. Remember, when you equate this one to 0, you get negative 3x, which is equal to 1. Then divide through by negative 3. So, then you get negative a third. So I advise that you use the x coefficient, the coefficient of x squared, the positive 1. Okay, what we did here by multiplying through by a negative, and then you change the sign, it simplifies the work. Okay, now here, since the coefficient of x squared is negative, then this is an n-shaped curve. And since that is an n-shaped curve, we are still having our values here, negative a third, and then here 5 over 3. So I can put negative a third and then 5 over 3. Now this is minus, and this is plus because it is above the x-axis. And we need a region below x-axis. So that means our x, it is going to be here and then here. X is less than negative a third, and also x is greater than 5 over 3, just like the one we got up there. Okay. Part B, it is given that y is equal to 9x plus k is a tangent to the curve. Find the value of the constant k. Now, if I have y, which is equal to 9x plus k, the gradient of this line is 9. Okay. Or I can say dy dx is equal to 9. Then I also have the equation of the curve, which was given as y is equal to 4 plus 5x, then plus 6x squared minus 3x cubed. Then when I differentiate this, dy dx is going to give us 5 plus 12x, then minus 9x squared. Then at the point of intersection, okay, the gradient is the same. Gradient of the tangent, is equal to the gradient of the curve. The gradient of the curve. So therefore, 5 plus 12x minus 9x squared is equal to 9. Rearranging this, we can have 9x squared. When I take this one this side, learn to use the coefficient of x squared, a positive one. Okay, then minus 12x, and then 9 minus 5, we shall get a 4, which is equal to 0. Then we solve this quadratic here. When we solve the quadratic here, you just get your calculator. Coefficient of x squared is 9. The coefficient of x is negative 12. And the coefficient of, the constant is a 4. Then I get 2 over 3. So x is equal to 2 over 3. X is equal to 2 over 3. And you can see that they never put x1. So that means it is a repeated root. So when I try to put another one, so it goes. So it was on the 1 value. So you can cross multiply here, then you get 3x. Then you bring the 2, so minus 2. And then this one has to be squared, okay? It's a repeated root. So x is equal to that 2 over 3. And then, remember, they told us to find the value of k. Now, since this is a point, these two intersect, there is a y coordinate. So we can find now the y coordinate for x is equal to 2 over 3. They have the same y coordinate. So what is the y coordinate on the curve? Y is going to be equal to 4, then plus 5. We are substituting here in the equation of that curve. 4 plus, we have 5x, which is 2 over 3, then plus 6, 2 over 3 squared, minus 3, 2 over 3 cubed. Then we can put this one in the calculator, all of it at once, and we see. So let me go to mod, put it back. So we have 4 plus 5 into 2 over 3, then close the brackets, plus 6 into 2 over 3, close the brackets, then you square, minus 3 into 2 over 3, close the brackets, and then you cube it. So this one gives us 82 over 9. So 82 over 9. Now, after getting that answer, it is the same y coordinate for this equation of the tangent. Okay, so we substitute in there. That means we shall have 9x plus k. We have y, which is equal to 9x plus k. So the y coordinate is 82 over 9, then 9, and the x coordinate is 2 over 3, then plus k. So meaning our k is equal to 82 over 9, then minus 3 goes here. How many times? 3. So 3 times 2, that would be 6. So minus 6 here. Now 9 times 6, that would be a 54. So 82 minus 54, you get 28. Let me see. So 82 out of 9, then we can subtract a 6. So we get 28. So that means k is going to be equal to 28 out of 9 as our final answer. Question 10. An arithmetic progression has first term 5 and the common difference d, where d is greater than 0. The second, 5th, and 11th terms of an AP in that order are the first 3 terms of the GP. Find the value of d. Now, an AP, they are saying the second, okay? The second term of an AP is given as a plus d, is now the first term of the GP. First term of the GP. And then the 5th term of the AP, which is a plus 4d, is the second term, okay? Second term of the GP. And then we also have the 11th term, which is a plus 10d for the AP, is equal to now the third term. The third term of the GP. So we know from the GP that common ratio can be got by getting the preceding term divided by the preceding term. What do I mean? I can get the third term divided by the second term, which is the same as the second term divided by the first term. Okay, so the third term of the GP is a plus 10d. Then the second term is a plus 4d. Then I can equate the second term is a plus 4d, which is out of the first term of the GP is now the a plus d. Okay, now we can cross multiply. When we cross multiply, we shall have a plus 10d multiplying with a plus d, which is equal to a plus 4d multiplied by a plus 4d. It is actually a plus 4d squared. You open the brackets, a times a, that is a squared, a plus d, that is ad, and then 10d times a, that is 10ad, and then 10d times d, that is 10d squared. When you open brackets this other side, you have a squared, then plus 4ad plus 4ad, and then 4d times 4d, that is 16d squared. That will be 16d squared. And then we can now simplify this one here. Okay. We can now simplify. Now, we were told that the first term of the AP is 5. So I can put everywhere there is a, I can put a 5. Okay. So I'll have here 25. Our a is equal to 5. Okay. 25, then plus 5d, plus 5 times 10, I think that is 50d, then 10d squared, which is equal to 25, then plus, this will be 8ad. So 8 times 5, that is 40d, then plus 16d squared. Automatically, this 25 will cancel with this one here. Okay. Then I can put everything onto one side. So 50d minus 40d. Then we also have 10d squared minus 16d squared. Okay. Actually, this one here is 55. So 5d plus 50d, that is 55. So I will write here 55d, and then this one will be equal to 0. So we can simplify this. 55 minus 40, that is 15d, and then 10 minus 6, that is minus 6d squared. Now 3d is common. That means here we shall have 5, then minus. Inside here we shall have 2d. Yes, 2d, which is equal to 0. So meaning I can equate the 3d to 0, and then the 5 minus 2d to 0. That means from here, d is going to be equal to, 2d is going to be equal to 5, and therefore d is 5 over 2, which is 2.5. Of course, d cannot be 0, okay? Because if the common difference is 0, that means you are having only one term. You are not proceeding to any other terms, okay? So that is the value of d, 2.5. Part B, the sum of the first 77 terms of the AP is denoted by S77. The sum of the first 10 terms of the GP is denoted by G10. Find the value of S77 minus G10. So sum of the first n terms, this is the GP. Well, the GP is equal to A into R power n minus 1 out of R minus 1. Okay, so we need to find the R for, that is the common ratio for the GP. Remember we said A plus 4D out of A plus D. If you can remember from here, okay, second over the first. So we are here. Or you can use this one, whichever. So I've used A plus 4D. then plus, out of a plus d. Now our a, by the way, our r here is going to be 5. So remember, a is 5. It was coming from the AP, okay? 5, then plus 4 times the d is 2.5 we have gotten out of 5 plus 2.5. So here you will get 10 plus 5, that is 15 over 7.5. Of course, now r here becomes a 2. Okay, and then the first term of the GP. The first term of the GP, which is the A here, it's not the other A, it's not this 5. Okay, the 5 is for the AP. Now for the GP, remember we are getting, this is the second term over the first term. So therefore the first term is A plus D. So it is 5 plus the 2.5, which is 7.5. Actually, it is here. Then now G10 is going to be equal to 7.5 into 2 power 10 minus 1 out of 2 minus 1. Okay, so this one can simplify to 7.5 into 2 power 10 minus 1. I can first leave it there, exact. Then I go to the AP. Okay, when we go to the AP, we know that sum of the first n terms of an AP is n over 2 into 2a plus n minus 1d. So they said that sum of 77 terms, so that is S77, we shall get 77 over 2, then into 2 times 5, that is the F for the AP, then plus, if it is 77 terms, now we have 77 minus 1, that will be 76 here, times the common difference, which we got as 2.5. Okay, now what does this one give us? We shall have 77 over 2 into 10, then plus 76 times 2.5. So this one gives us 7,700. Now, S77 minus G10 is now going to be 7700 subtract 7.5 and then 2 power 10 minus 1. 2 power 10 minus 1, we have 7.5 into 2 power 10, then subtract 1. This one gives us 7672. So we have 7700 minus 7672.5, and then when we subtract them, you can just say minus 7700. So this one will give us 27.5. 27.5 as our final answer. Question 11. The function f is defined by f of x, which is equal to 3 plus 6x minus 2x squared for x being real. Part A, express f of x in the form a minus b into x minus c squared, where a and b are constants, and state the range of the function. So we have our f of x here, which is equal to negative 2x squared. I can put it in decreasing powers of x. So the coefficient of x squared is not, this one I can do it in two ways. Okay. Number one is complete squares directly. So since the coefficient of x squared is not 1, I first factorize it. So this is negative 2. Then here I have x squared, then plus, now this one will be a negative because you are not supposed to change the meaning. So minus 3 of x. I can leave the 3 outside here. Okay, so -2 times the -3, then I'll get the +6 here. Now I get the coefficient of x. Okay, I divide it by 2, and then I put it together with x in brackets. So the coefficient of x here is -3. You divide it by 2, put it together with the x here, then pop it out as a square. So 3/2 squared. Okay, then close the brackets, then there is this +3. Then now you can open up the brackets. We can have -2 multiplying this x minus 3/2 squared, and then you have 9/4, then times the -2, then +3. So we shall have -2 into x minus 3/2 bracket squared, and then we have here plus 9/2, then +3. So 9/2 is actually 4.5. So +3, you get 7.5. 7.5 is the same as 15/2. So that means in the format here, they told us to express this one into, it will be 15/2 minus 2 into x minus 3/2 brackets squared. So this is our answer here. So alternatively, like I said, there is another one. You can expand and equate coefficients. So your 3 plus x, 6x, then minus 2x squared. Then you equate to this one, a minus b into x minus c squared. Open the brackets, minus b, then square, you have x squared minus 2cx, then plus c squared. When you open fully, you have a minus bx squared plus 2bcx minus bc squared. So this therefore means that we can have 3 plus 6x, then minus 2x squared. So the constant, we are having a minus bc squared, and then the term in x here is plus 2bc of x, and then minus bx squared. Now we equate coefficients. So the coefficient of x squared is -2. So we equate these ones here. Okay, so minus b, sorry, let me just write this one this way. -2 is equal to minus b. Okay, so meaning b is equal to 2 when you divide all through by -1. Next, the coefficient of x here is 6. So I equate it to this one here, 2b c. That means my c is going to be 6 divided by 2 times the 2. This b is a 2. So meaning c is going to be simplified to 3/2. And then what else is remaining is a. So where do we find a? We find a here. So the constant part. So we say 3 is equal to that a minus bc squared. So this is 3 plus now the b, which is 2, and then the c is 3/2 squared. That will give us a. So this is 3 plus, this will be 9/4, then times 2, that will be 9/2. You see? So your a is going to be that 15/2. So therefore, your f of x, now you can substitute in the values here, the values of a. So you have 15/2 minus your b is a 2, then x minus c is 3/2, and then squared. So this will be your answer. So either way, you get it. State the range of f. Now, for the range of f, we need to look at the sketch of that graph. Since the coefficient of x squared from here is a negative, That means this is an N-shaped curve. Okay, this is an N-shaped curve. So by doing a small sketch here, then what we have gotten here, if we have the curve, the equation of the graph of the quadratic curve given in the completed square form, a into x plus or maybe minus b squared then plus c, the turning point is given by b, c. So when you put b here, this one disappears, and then what remains is the c, that is the y coordinate. So that means from what we are having here, the turning point is 3 over 2, and then the y coordinate is 15 over 2. Now this is a maximum point. So meaning all values of y are going to be below this point here. Okay? All of them are going to be below. This one is the maximum. So that means the range of f is going to be given by f of x less than or equal to 15 over 2. Range is given in the form of the function, and the domain is given in form of the independent variable, like for this case, the x. Okay, so that is that. Part B, the graph of y is equal to f of x is transformed to the graph of y is equal to h of x by a reflection in one of the axes followed by a translation. It is given that the graph of y is equal to h of x has a minimum point at the origin. Give details of reflection and translation involved. Now, to give the details of what is involved here, first of all, let me make a small sketch here. Okay, a small sketch just like I've shown you up there. So we are having a point here. Okay, the 3 over 2 and then 15 over 2. So this is an N-shaped curve. Okay, an N-shaped curve. This is y. So we are going to reflect this one in x-axis. If we reflect it in x-axis, the x-coordinate is going to remain 3 over 2, but the y-coordinate is going to change the sign. It's a negative. Then now we can move this one this way. Okay, and then we also move it up. So we are going to move it to the left by 3 over 2 or by negative 1.5 units to the left. And then since this is minus 15 going down below x, then that means we shall go up positive, and we shall go up by 15 over 2 units. Okay, so that means we shall have reflection. Remember, we are taking this one to the origin, so reflection in x-axis. Then the other one is going to be the translation in, the translation by the vector. So which vector? Negative 3 over 2 and then 15 over 2. So these are the transformations that are going to transform our f of x into h of x. The function g is defined by g of x is equal to 3 plus 6x minus 2x squared. The same function that we have been dealing with for x less than or equal to 0 for the negative values. Okay, remember that function is n-shaped. Okay, is n-shaped, but now they want only the what? The negative values. Now they are saying sketch the graph of y is equal to x and explain why g is a one-to-one function. You are not required to find the coordinates of any intersection with the axes. So if I try to sketch, this is my these are my axes, Then I can have this as y, this one as x. Now, here I'm going to have, then another thing, if you can look at D, they said sketch the graph of y is equal to the G inverse on your diagram in C. So these two, the relationship between these two is that they are mirror images of each other in the line y is equal to x. They are mirror images of each other in the line y is equal to x. So let me even make it, let me make this one dotted. Okay. This is the line y is equal to x. Remember, when we are finding the inverse of a function, we interchange x and y. So that's why they are mirror images in this line. So this one, remember, it's an N-shaped curve because the coefficient of x squared is what? Negative. So it will come like this. Okay. Now that means that the G inverse, so I can label this one to be my y is equal to the G of x. And then the G inverse is going to be this other one here. Let me put another color. It will be like this. So the coordinate that is here is the one that is here. Then the one here is the one that is here. Because when you are reflecting, the line connecting the object to the image point is always perpendicular to that line. Okay. So you don't need to be so accurate, okay, when it comes to the sketches, but it is going to look like that. So this is our y is equal to G inverse of x. Now, when you go back to this equation, I mean this question here up here, we are having the h of x. It was given for all real values, all real. Okay, so meaning we were having values of it on the left and on the right of the turning point. Okay, so that one wasn't one-to-one because for one value of y we were getting two values of x, so that wasn't one-to-one. And functions which have inverses are the ones which are one-to-one. So now here they are telling us that find they said here that explain why G is a one-to-one function. So G is a one-to-one function because every value in the domain is assigned to one value in the range. Okay, so I can write it like this, that each value of y is associated with one value of x. Okay, so this is why G is a one-to-one function for x less than or equal to 0. So if they want to make the function one-to-one, they have to choose one side of the turning point. Is it the left or the right? Okay, so I want you to pay attention to the sign that they give. So this one is a less than. That means when we are finding the inverse of a function, then we are going to take the minus sign. If it is on the right of the turning point, then we take the positive. Okay, now part D, we have already sketched. Then they are telling us that find an expression for the G inverse. You should label the two graphs in your diagram appropriately and show any relevant Miller line. You see the relevant Miller line, y is equal to x. Okay, that is that. Now let's go to if you are to sketch just like I said, if you are to sketch the inverse of the function, you just reflect the function in this middle line y is equal to x. All right, now let's find the G inverse. So our G inverse, our G is 15 over 2. Remember that this same function here they have given us, it is the exact one that we expressed as the completed square format, which is here. The completed square format is the same. So we are going to write this same thing here, 15 over 2, okay? 15 over 2 minus 2 into x minus 3 over 2 brackets squared. Okay, now the G inverse, let our G inverse be equal to y. So if I take this one, this other side, x will be equal to the G of y. In other words, interchange x with y. So we shall have our x here, which is equal to 15 over 2 minus 2 into y minus 3 over 2 squared. Now I can take this whole thing this way so that it becomes a positive squared. Then take the x this other side, 15 over 2 minus x. Okay, then make y now the subject. So to make y the subject, divide all through by 2. This is y minus 3 over 2 squared. 15 over 2 divided by 2, that will be 15 over 4, and then x divide by 2. Then now take the square root on both sides. Okay, the square root, remember when we take the square root we have plus or minus, so 15 over 4 minus x over 2, and then take this one this other side, becomes a plus. But now when you write your answer with this plus or minus, you won't get your answer correct. So since the domain of G of x is x, let me even write it here. Since the domain of G of x is x less than or equal to 0, they use the less than sign, okay? We take the negative sign. Okay, so you can now conclude and you say that your G of x, the G inverse of x is equal to 3 over 2 minus the square root of 15 over 4 minus x over 2. So that is our answer there. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and subscribe. See you in the next videos.